Okay, Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. In this video, we'll be discussing about how to use Kirchhoff law. So, we will discuss question number 12 and question number 13. For question number 12, determine the values of current through R1 and R2 in the circuit shown in figure 3.4, given that when S1 is open when when S1 is closed. So this is the circuit on the right here. So if you want to find when the S1 circuit is open, it actually looks like this. So if it is like that, basically you can assume that there's nothing here because the current wouldn't flow over there. So you can simply ignore this part. Okay, so this is how the circuit looks like. Okay, now you have to determine the direction of current and direction of loop. Okay, how do you know that you need to apply the Kirchhoff rules, Kirchhoff law? Because here you have more than one EMF. Power supply lah, 1, 2. Okay, even though here it only involves one loop or there's no junction, so you can apply the loop rule over here. So how to apply the loop rules? First thing, you determine direction of loop. My suggestion is that you always follow the one with the largest EMF. So in this case, my loop direction follow the 6 volt. So it looks something like this. Okay, so this is my loop direction. So this is my loop direction. How about my current direction? My current direction, normally I would try to follow the loop direction as well if it is possible, and in this case it is possible. So this would be my current direction. Direction of I and direction of loop. Okay, now how do you solve it? You can start with you can always, basically, if you want to apply the loop rule, basically you want to apply summation of EMF equals to summation of IR. That means sum of the voltage gain equals to sum of the voltage loss. So normally voltage loss in the resistor, voltage gain in the EMF, it depends on the direction as well. So in this case, it will be 6. I'm going to start from here and I'm going to flow it over here. But I'm going to do the EMF first. I'm going to do this side first. So I'm going to focus on the EMF only for the first step. So it will be 6, positive 6 to be exact. You don't have to write the positive. Kenapa positive? Because you have to follow the loop direction. Loop direction yang pink color ni, they actually coming out from the positive terminal. Okay, dia keluar daripada sini. This one is positive. Yang longer ni positive, so the positive. Over here, loop direction is in this direction. So actually they're coming out from the negative terminal. So that one is negative. So it will be negative 3 equal to, so basically we have 3 resistor, 1, 2, 3. So you would expect to have 3 term over here as well. Okay, so I'm going to start with this one because next to the first one kan, tak kisah mana start daripada mana. So I'm going to start with this one and I'm going to flow in that direction, in the loop direction as well. So the first one, my current direction is to the left, my loop direction to the left, so it will be in the same direction. So that one is positive, so positive IR. So I just write it over here as I. My resistor is 4. Okay, there's no junction. That means the current inside the circuit here is the same. So basically you only have one I. Okay, that's why the question wanted to find R that flows to R1 and R2. And then for the next one, for this one, current direction to the right, loop direction also to the right, so that one is positive as well. So it will be positive, still I, 3. Okay, and then over here The last one is I positive 5. So this one is positive as well. It's over here actually. So the current direction is going downwards. The loop direction, it will be going downwards over here as well. So same direction, loop and current direction, so it will be positive. So now it's a matter of solving it. So it will be 6 minus 3, which is 3. And then this one is 5 plus 3 plus 4. We get 12i. So it will be 3 divided by 12, which is 0.25 ampere. Senang kan? Memang senang. So don't worry too much. Okay, what if S1 is now closed? So just now it is open, so kamu jangan confuse open and close. Open, the switch is open. If it's closed, then it's connected lah. So when this one is connected over here, what will happen is that if the current want to flow over here, that's how I use this color, right? So current, let's say current want to flow over here, they will try to split into two direction current lah. So it will be I1 and I2. Let's say this is my I1 and this is my I2. But the current, dia pandai sikit. So dia nampak one path yang atas ni, there's no resistor. Yang bawah ni ada resistor. So the current will choose the easiest path. So dia akan ikut atas tu. So in fact, there's no current over here at all. No current. So when there's no current, so basically you can ignore. So basically dia jump. So this circuit actually dah dilompatkan. Resistor ni dia dah dilompatkan. So dia tak kena lah. So I'm going to erase everything over here. Okay, I'm going to erase everything over here. Okay, that one as well. So I'm going to left with a straight line, just like that. So you imagine once the switch is connected, it's closed, and then you have something like this. You use the same concept. First, you want to apply the Kirchhoff rule, the loop rules. You need to determine the direction of loop first. Follow the biggest EMF here. So I'm going to follow that one. So it will be in this direction and that direction. Okay, this is my loop direction. And then current direction I choose in the same direction as my loop. Again, I told you previously during lecture notes discussion, it actually doesn't matter whether you choose the loop direction and current direction. So the way I choose it to make things easy afterward. So if you follow my method, it's not my method, but the method that I use, it will becomes much easier. So now you want to apply the loops rule. Okay, so the first one I start with the 6 and then 3. So again, this one is positive because coming out from positive, and this one is negative because coming out from negative. Remember, EMF follows the loop direction sahaja. Positive 6 minus 3. Okay, current, you only have one I, but now you only left with two resistors here. So for the first one, current to the left, loop direction to the left, same direction. The second one, downwards and downwards, so same direction as well. So I'm going to do this a little bit faster. So it will be 4i plus 5i. So I will have 3 equals to 9i. So it will be 1 over 3, which is basically 0.333 ampere. Okay, for question number 13, actually it has two questions, A and B, but we're going to try to do question number A first. Okay, if you look at the diagram here, you can see that actually the tricky part is over here, the one with the diagonal. So what I'm going to do is that I simply replace that one into something that we are more familiar. So I already draw this one, so it is much simpler, and then I think this one kamu dah biasa tengok, so should be okay. So basically it consists of two loop, so you have to apply junction rule as well as loop rule. So macam biasalah, first thing first, I suggest you to color the current separately. So example over here, let's say this one is my I1 contohnya lah. So let's say I put as I1, I leave out the direction first. So this is my I2, and my I3, let's say it's this one. Since the question didn't give you any direction of I or any labeling of I, you can simply decide it yourself, tak kisah. So this is my I3. Okay, every time you redraw your circuit, always double check. This one I already checked lah. So make sure you have 2 junction, and then make sure you have 3 resistor. Okay, so my method of drawing this, actually I start again, it's the same method previously. Start from the positive terminal, go through the resistor like that. Positive terminal, go through resistor, and then a junction, the green junction. Okay, then this junction split into 2. One is this one, 18 ohm, and then that one is another junction. This one I just rearrange so that it looks like a squarish like this. Okay, and after that, from that junction, it goes back to negative terminal. Okay, now once you do that, the first thing, if you want to apply loop rule, obviously you need to have loop direction. So this is my loop direction. Follow the one with the largest EMF. So you have 2 power supply, 6 and 9. You would use the 9. You would follow the 9. So loop direction will be in this direction. Okay, and then another one will try to follow this one. So in the middle here is actually going to the left. So my next loop direction is something like this. Okay, so this question sebenarnya memang obvious you have to use Kirchhoff rules, because memang nampak ada 2 loop. Macam yang question sebelum ni, ada 1 loop tapi dia ada 2 EMF. Okay, now once you decide your direction of loop, I label it over here, and I label this one as my loop 1 and loop 2. Okay, after that, current direction. So my current direction will always I will try to follow the direction of loop. So in the middle here, direction of current, maybe I can draw it like that as well, to the left as well. And then down here, up, and then this one going up like that. So I1 to the left, I2 upwards, and I3 downwards. Okay, to solve this one, the first thing you can apply is you can apply junction rule. Okay, so junction rule, where summation of I in equals to I out. So most of my drawing involve with the purple junction though. So I'm gonna take that junction. So the I that is going in is actually I1, and I2 and I3 is going out from the junction. So this would be my first equation. Okay, my second equation is actually loop rule, where summation of EMF is equals to summation of IR, gain equal loss. So I'm going to start with the loop 1 first. Okay, I think I might have to bring this one to the other page. Okay, so to use the loop law, you can start from the positive terminal. So we want to start from the loop 1 first. So we start from here, and we follow this direction. Okay, so the EMF is positive because it's coming out from the positive terminal. So that one's positive 6, and then equal to, or the voltage drop, which is for the resistor, Okay, over here we have direction of current, which is, if you follow this direction, I2, it will be downwards here. Okay, loop direction also pointing downward. So I can substitute straight away IR, which is basically I2 12. So I rewrite in terms of 12 I2. Okay, this one is positive as well because current and loop is in the same direction. And then for the second resistor, loop direction to the left, current direction also to the left, but notice that this one is actually I1. Okay, just now is I2, this time is I1. So if you color different component, different area with different color, so it should be obvious. Over here, red color I1. So it will be positive 18 I1. So this would be my second equation. So previously this one is my first, now I have second equation. My third equation will come from the second loop. Again, I'm going to start from the EMF here, so it's coming out from the positive terminal, so it will be positive 9 equals to, you have two resistors here and here, so the first one will be positive because current to the left, loop direction to the left as well, so it will be positive 18 I1, red color I1. Okay, for the last resistor will be positive as well because direction of currents pointing downwards, direction of loop going downward across the resistor. So positive 8 I3. Okay, so common mistake would be student mix up with numbers of current lah. I2, I1 dia terbalik sebab dia tak label properly. Now we can try to solve this one. Before you press your calculator, I strongly suggest you guys to rewrite the equation, all the equations. So we have three equations. I1 equals to I2 plus I3. So I want to bring the one with the I to one side, the one without any I to the other side. Okay, yang ada variable saya bawa ke side, ke kiri. Yang tak ada variable saya put it to the right hand side. So I have I1 minus I2 minus I3 equals to 0. Okay, I mean kalau kamu nak buat cantik lagi, maybe you can write positive 1, negative 1, negative 1. Tapi tak perlulah. And that one would help for you to press inside your calculator, to key in inside your calculator. Excuse me. So the 6 is basically dah satu side, so the remaining one side already, so should be okay. Okay, so 18I1 plus 12I2, and then there's no I3, so I just put 0 I3. I put 0 so that you don't get confused when you try to enter inside your calculator. And then the third equation, again, all the variables is already in one side, so it will be 18I1, sorry, yes, 18I1 plus 0 I2, there's no I2, but you have I3, which is 8I3 equals to 9. Okay, so what you're gonna do is that you have to enter inside your equation, inside your calculator. This will be your first row, second row, third row. Okay, remember to choose simultaneous equation, persamaan serentak dengan 3 variables. So the first row kamu isi 1, negative 1, negative 1, and then 0. Okay, setiap kali kamu enter, kamu tekan equal. So the second one would be 18 and then I have 12, 0, and then 6, and the last one would be 0. So the last one would be 18, 0, 8, and 9. Okay, here I got my I. Oops, saya tulis. Okay, and then my I3. Okay, so obviously sometimes you might have the negative in the opposite pair. So here you can see that I2 ada negative. I got my answer I2 ada negative. Sometimes you might get I1 and I3 ada negative, tapi yang ni tak ada negative. Okay, it really depends on the direction of current that you choose over here. Okay, so what does it mean by negative I2? Is actually I2 is actually pointing in this direction instead of that direction. Dia actually masuk towards the junction here. Tak ada masalah pun. Kalau dia tanya direction of loop current inside the first loop, then you can answer lah whether it is clockwise or anti-clockwise. Biasa dia tak tanya pun. So sometimes I1, I2, I3 kamu label kat tempat lain, so you might get a different answer. Tapi nilai belakang ni mesti sama. So current, they will look into your final value over here, the magnitude there. Okay. Okay, for question number 13b, you are given a circuit. So immediately you can see that there's two loops over here, so you know that you have to apply Kirchhoff rules. So it will be the first loop and the second loop. The only difference between this question and previous question is that now they did give you the direction of current, one of the current, and the values of one of the current. But now they want you to find the EMF values over there. So macam biasalah, first thing first, you label the current punya color. Okay, let's say my I represent by green color. So this part is actually my I punya area. And then this one is another I. Okay, maybe I label this one as my I1. Okay, I2 kot. Yang dekat sikit tu saya pakai I1. And this one yang the middle here, I use I1. Okay, I haven't determined the direction yet. Okay, I just leave it like that. Okay, now I can determine the direction of loop. So you just want to follow the biggest values of EMF. You don't know this one, so you left with this one. So I'm gonna follow this one. So towards the positive, so it will be in this direction. For the first loop, I want to draw it something like this. Okay, so it will be in this direction for the first loop, and for the second loop, I'm gonna follow that one for the middle path. So it will look something like this. Okay, that one is the loop direction. Okay, now about the current direction. So direction of I is given. Okay, so if you want to solve, you have to apply junction rule dengan loop rule. So if you want to apply junction rule, you have to determine whether you want to use junction A ataupun junction B tu lah. So I'm gonna choose yang junction below there, down here, because I dekat situ, dekat sikit saya nak buat. And then I1, maybe I can draw it like this, in that direction. Okay, and then I2 maybe in that direction. Macam mana saya tentukan, dia tak kisah pun actually, but I just want to try to follow as something towards the same direction with the loop direction. Saya cuba nak ikut. Kalau tak possible, then tak apa, letak je. Now you can solve. So how are you going to solve this one? You can apply junction rule first. Summation of I in equals to summation of I out. So So I choose the red dot there as my junction. So the current going in will be I1, current going out will be I plus dengan I2. So straight away maybe I can write my I with the value itself. Kalau takkan saya akan substitute juga. So saya tulis straight away 2. Okay, this is my first equation. I'll leave it like here, like this first. Okay, the second one, obviously I have to apply, this one is Junction Rule. Okay, now I'm going to apply the loop rule. Summation of EMF equals to summation of loss across the resistor IR. Okay, so for the first loop, I'm going to start from here, and then I'm going to go to the second EMF, and then I'm going to do the equal sign. So it will be positive 12, because this one is coming out from the positive terminal, plus positive EMF, okay, also from the positive terminal. So this is the loop direction, positive terminal there, positive terminal there. Okay, now you're left with 3 resistor. The first 2 resistor is still under the same current, which is 2. Okay, so current pointing upwards, loop pointing upwards. Current pointing to the right, loop pointing to the right. Current pointing downwards, loop pointing downwards. So for these 3 resistor, basically the values of IR is positive. So it will be 2 multiply 2 for R1. For R2 it will be 4 multiplied by 2. Okay, and then for R3 it will be I1. So it will be 4I1. So I can simplify this one a little bit. We get 4 plus 8, which is 12. So minus with 12, I left with EMF equals to 4I1. Okay, so now this is my second equation. Okay, for the second loop, I can solve using EMF, which is equals to positive 12. This one is positive because coming out from the positive terminal, it flows in this direction. We've got 2 resistor here. One resistor multiply with I2, another resistor multiply with I1. Loop direction upwards, current direction upwards, same direction. Loop downwards, current downwards, same direction as well. So both of these is positive as well. So it will be 12 I2, you don't know the values of I2, plus 4 I1. Okay, I'm gonna recheck this one. So positive 12 here, this one is 12 I2, and then going back here it will be 4 I1. So this will be my third equation. So I can rewrite all these 3 equations so that you can see clearly what you're going to do next. I1 plus 2 plus I2. So I think I'm going to just copy it like this. Okay. Okay, and tu pun nak ikut juga. It's okay. So I rearrange a little bit. Okay, so now you have 3 equation and 3 unknowns. The first thing that you can do that I can see here is that I can try to substitute I1 here inside this equation. So I will have 2 plus I2 there inside here, and just I2. So I think I can solve that one. So maybe you have a different step, so it's okay, doesn't matter. Subs 1 into 3. Okay, so now I'm going to substitute equation 1 into equation 3. So I have 12 equals to 12 I2 plus 4 I1 is 2 plus I2. Okay, open up the bracket, we'll get 12 I2 plus 8 plus 4 I2. Okay, I can bring the 8 to the other side, so I left it 4 equals to 16 I2. So my I2 here is actually 1 over 4, which is 0.25. Okay, jangan hilang dia punya subscript I2. Okay, now let's solve the next step. Okay, I can substitute values of I2 inside my first equation. Substitute I2 into equation 1. So I'm going to have I1 equals to 2 plus 0.25. I got here is 2.25 ampere. Okay, so I have I1 and I2. Now I can solve epsilon. So substitute I1 into equation 2. So it will be 9 volt. Okay, so this is the answer. Because the question just wanting to find this one, you can straight away find this one. Okay, one thing that I would like to remind you guys, when you try to do, basically you decided the direction of current yourself, because the question didn't give you direction of current. So it really depends on which one you substitute, which one you represent this one as I1 or I2 ke, mana yang kamu letak simbol tu kan. It really depends on those, and kamu punya jalan kira will follow those things. So suggestion saya, elakkan compare dengan kawan kamu directly. Macam okay, kamu nak check mana salah kan, so kamu tengok side by side, tapi dia label yang lain, kamu label lain. So obviously I2 and I1 kamu terbalik jugalah. And then it really depends on the direction here as well. Current punya direction tu macam mana. Okay, so jangan compare directly halfway macam tu. If you want to check, you have to go through one by one. Okay, and then that's why dalam exam biasanya they will give you direction of current. Most of the time they will give you direction of current because nak check senang sikit. And you can check final answer sepatutnya sama lah, tak ada masalah. Kalau yang contoh macam soalan yang before this, final answer maybe sebab kamu label I1, I2, I3 ni dekat position yang berbeza, so the values of ampere ni, current ni maybe kat tempat yang berbeza lah. Itu je. Kalau dapat negatif, maksudnya the values of actual current punya flow opposite. Contohnya I2 ni kan, kamu initially assume it is actually moving in this direction, so since this one is negative, tapi sebenarnya adalah moving in that direction. Tapi kamu tak perlu sebut pun kalau dia tak tanya. Okay, you just leave it like this, biar je jawapan macam tu, tapi list down. Yang ni saya tak list down sebab question dia memang straight away tanya EMF. Okay, thank you. That's all for this video.